radians and arc length. So you guys need to know what those are. So first of all, you need to remember that circumference equals pi times diameter, right? Or why did I do divided by diameter? I said times. So pi times diameter. So the pi is equal to the circumference over the diameter. Circumference, if you guys remember, is the perimeter around a circle. So it's like if you put a fence around your yard, right? You call it perimeter. If it's a circle, we call it circumference. I don't know anybody that, I guess you might put a circular fence around like a pool or something. If you have like a above ground one. You know, like on a deck, like they have to round it. It wouldn't be like a square deck, you know what I'm saying? Like if you put a deck on a like above ground pool, you would probably make it more like to the shape of the pool.
Why are you putting a deck on a pool?
I'm so confused.
Don't worry about it.
Why would there be a fence?
Irrelevant.
You're so confused.
All right. Anyways, the blank of a circle is the distance around the circle. So the circumference, it doesn't matter. Don't worry about it. So the circumference, I was trying to use something that was applicable and it didn't work.
Who brought that to school?
One of my freshmen. All right. So the circumference of a circle is the distance around the circle. We find this by using the formula pi times diameter. So we use this by using pi times diameter. Guys, please. If we write the formula using the radius instead of the diameter, we do 2 pi r. So these should be familiar to you. These are the circumference formulas. Sometimes you'll do 2 pi r or you'll just do pi d. It does not matter which one you use because the radius is half the diameter. So if you double it, it becomes the diameter. So that's the first thing there. By circumference?
Why is there 2?
Because circumference is pi d, the radius is half the diameter. So if you multiply it by 2, it becomes, yeah. So this is a radius, yeah.
I didn't know colors.
Yep. All right, guys. Are you sure you're okay now? You okay now?
Oh, yeah.
Okay. So we normally use degrees as a unit of measurement when describing angles, or like a distance around a circle, like we use degrees too. But there is another unit of measures for angles. This measure is called radians. It's the measure of the central angle of a circle that intercepts an arc in the length of the radius of a circle. So radians have to do with the fact that a circle has a relationship to this pi and the radius is 1. So we are going to watch a quick clip real quick here. So you guys can see this and you can fill in the blanks. We'll fill them in together really quickly too. But let me play that for you guys. So it's trying to show you this relationship of what a radian is. So the circle had a radius of 1 is what it was showing you. And we know that the circumference is equal to 2 pi. 2 pi r, right? So what we learned is how many radians were there in a circle with a radius of 1? How many total was it? Half was pi, so the whole was 2 pi. So there's 2 pi radians, which is the same as 360 degrees in a full circle. So these two things are the same. They're just different relationships. It's kind of like being measured, and like if you get your measurement at the doctor, sometimes they'll do it in like centimeters or meters or whatever, and sometimes they'll do it in feet, right? If you go to the doctors, you know how there's 2 different units of measure for like length and stuff like that? It's the same thing. This is just a different unit of measure. So 360 degrees is the same thing as 2 pi. So you guys have done conversions before, right? You guys have done conversions before in science. Probably physical science is when you do them the most. Maybe 8th grade a little bit too. And they call them the train track problems, maybe. You know what I mean? Where they set up the train tracks for you and you multiply things out. So we can convert from one to the other. We know that 2 pi radians is the same as 360 degrees. So if we want to go from degrees to radians, we need to keep our pi in the top of the answer. So if we're going from degrees to radians, and we divide this, that is pi radians. What's half of 360? Over 180. And that will get you from degrees to radians. So I divide it by 360 degrees on both sides. So we will talk about how we're going to use this. We're going to do a ton of examples in just a second here. And hopefully the pattern will emerge. And I'll give you guys some tricks and stuff like that too. So go ahead and write this down. And then we are going to do a bunch of examples to help you guys out. If you don't have a calculator, grab one now. If you do not have a calculator, grab one now. So here is our conversions. Here are our conversions. These are the big things that you need to know in order to convert. So this is becoming degrees to radians. So that's degrees to radians. And this one is radians to degrees. So you know which way you're converting. It's important you know which one is which. All right, the next thing you need to realize is that radians needs to have pi in the numerator. So you'll notice the relationship. These are not that different. One is pi over 180, right? And the other is 180 over pi. Here's how you know which one is which. This is going to radians because radians must have pi in the answer. So that's why it is in the numerator. So you know to use pi over 180 when you're going to radians because radians has to have pi in the answer, right? 360 degrees is the same as 2 pi radians. So that's one way to know that that's why pi needs to be in the numerator there, on top there. You know you're going to degrees when radians is in the denominator because you need to get rid of pi to go to degrees. So, again, there's not much to memorize here. It's either 180 over pi or pi over 180. Do you guys see that for the conversion? So it's really not that different here. The big thing you do need to realize here is, though, that radians must have pi in the answer, so that's why it's in the numerator. So if you're going to degrees, put that pi in the bottom. Put it in the denominator. So how can you tell if something is radians or degrees? Well, you'll notice that degrees will have this little circle here, which is the degree symbol, right? In radians, it will have pi as part of the answer, or as part of the problem, okay? So that's how you can tell if it's radians or degrees. So these are degrees. So if we are going from degrees to radians, which is what this one is, we are going to multiply by pi over 180. Because we want to go to radians, that pi needs to be on top. That symbolizes that we're in a radian there. So we can kind of do some cross division here. You'll notice that they both end in 0, right? Do you guys see that? Do you guys all see that? This is 40 pi over 180, so we need to simplify this. So you multiply straight across. They both end in 0, so I'm going to cross off those zeros. What goes into both 4 and 18? 6 goes into 4?
No, it's not.
What goes into both 4 and 18? 2. So if I divide both by 2, I get 2 over 9. So this is 2 pi over 9 radians. You can put rad after it if you want to. So again, if there is a degree in the original, we multiply by pi over 180 because a radian needs to have pi in the answer, so it needs to be in the numerator. So we would have 165 pi over 180. What goes into both 165 and 180, guys? 5. Okay, so we divide 165 by 5 and we get, what is it?
33.
We divide 180 by 5 and we get, guys, this is why I told you to grab a calculator.
36.
Does anything go into both 33 and 36? 3, okay. 33 divided by 3 is 11, and 36 divided by 3 is 12. So this becomes 11 pi over 12 radians. And I'm just going to put rads. So you notice, am I just multiplying and I'm done, or do I have to simplify? You have to simplify. And these represent the same angle in the unit or in a circle. So if you're talking about a 40-degree angle and this is 90, 40 degrees is here, and that is the same as a 2 pi over 9 radians. So that's all we're doing here, is we're just saying another name for 40 degrees is 2 pi over 9. That's all we're doing there, okay? Just like I could say I'm a certain height in feet and a certain height in meters, yeah.
Is there a way instead of like simplifying, we just like write 165 pi divided by 180, like over 180 in your calculator?
You could do 165 over 180 in your calculator. So do 165 divided by 180 in your calculator. Hit enter, and then change it to a fraction to decimal, and then just add pi to it. Does that make sense?
Yeah, can we do that instead? Like,
Yeah, so here's the other way we can do it. So I'm showing you why your calculator is doing that. So, again, this is in degrees, so we're multiplying by pi over 180, right? So this is 300 pi over 180. So what you guys could do, but make sure you're not using mixed numbers, you're using improper fractions, okay? So if you do this, you could type 300 over 180 in your calculator. So go ahead and do 300 divided by 180 in your calculator. Change it from fraction to decimal, and it will give you a mixed number. And then change that mixed number into a improper fraction. Does anybody not know how to do that on their calculators? Because there's buttons that you can click. Yeah. So you will literally, you're doing the wrong way. It should be 300.
oh.
And then all you have to hit is this S to D button, and you're there. Okay? Anybody else?
Miss Buddy.
Yours will be the S to D button once you do
Oh,
it.
no, but mine's like different.
Okay, so you'll hit second. You see this F to D above here? That means fraction to decimal. Hit enter. And hit enter. And then you can just do like 1 times 3 plus 2. You know what I'm saying? Or, do you know how to change it? Okay. Or you can do hit second again, and then you see the ABC button, how it goes A, B, C, D, E. That's saying put it into an improper fraction. So hit that now and hit enter. And that's 5/3. So you should get 5/3. Who else needs me to show them? Maybe didn't figure it out on their own. You should just be, you need to type it into your calculator. So do 300 divided by 180. And then you hit second, F to D. So it's the PRB button. It means fraction to decimal. Hit enter. And then you'll hit second again, and you'll hit the ABC button because it says ABC to DE. That means improper fraction. Okay? I don't know. I'd have to look at yours a little bit more. Okay. All right, guys. Or you could just do it by hand. They both end in 0. I know 6 goes into both of those, so I'm going to divide both by 6, and I get 5 pi over 3 radians, right? Did you guys get that by using your calculator or by just dividing it? Yes. I don't care which way you do it. So I'm going to skip some of these other ones, and we're going to do some radian ones. What's up?
Whenever it's like the radical over 6, because you know it's like 1 radicals over 6, do we have to have 1?
Or can we just do radical?
What are you talking about?
Right here.
Because it simplifies.
Yeah, no, you could just do pi over 6
Okay,
radians.
I didn't know if that was...
Yeah, so like they just looked at this one. We multiply this by pi over 180, right? If I multiply that, 3 goes into both of those. So that's 1 over 6. So that's pi over 6 radians. Do you guys see that? You could put the 1 there. You don't have to. All right, so you guys notice that these ones have pi in the top, right? Do you guys all see that? We need our pi to be in the denominator so that it cancels. Do you see if we have a pi in the numerator and a pi in the denominator, they go away? Which we don't want pi in our degree, so that makes sense. 18 goes into 180. How many times?
10.
So this is just 10 degrees. So you know what a 10-degree angle looks like. Something like this, right? But you probably didn't know what a pi over 18-degree angle looked like. So that shows you what it looks like in a unit that you guys are used to. Does that make sense? So again, what are we going to multiply when pi is in the numerator there? We want the pi to go away, so we put the pi in the denominator so that it goes away. So you'll notice here that pi will go away. Do you guys see how we have a 5 times 180 over 12? So you need to multiply across first. And I'd have 900 over 12, and then just do 900 divided by 12. So make sure you multiply. What is it?
75.
So this is almost easier to go this way, right? Do you guys see this? This is a little bit easier to go this way, maybe. Or maybe it's not. Maybe the other way was easier for you. Everybody's different.
Wait, so we just like multiply across?
Straight across. And then divide. Okay? Okay, so for the next one there, pi is in that numerator, so we are going to divide by pi. So we'll do 180 divided by pi, so that goes away. I multiply straight across. So I get 720 over 9, which is
80.
80 degrees. Okay, so I'm going to stop unless you guys need me to go over something else. Are we okay with these conversions here? Yes. For you have this DC button here that I wonder if you could, for like this one here, 300 divided by 180. So you have F to D here, so you'll hit second. This button here, that changes it to a mixed number, and then you'll hit second ABC, and that changes it to an improper. Or, yeah. Does that make sense? Lindsay, goodness. I called you Lindsay there. Jillian, I need to look at your calculator because I think it's within the math function there it's in like a folder, okay? All right, so what is arc length? Arc length is a proportion of the circumference of a circle. We can use the measure of an arc in degrees or radians to find its length. It's linear units. So, so be careful. There is a difference between a measure and a length. We have been dealing with measure over the past couple weeks. All right, so the quiz you guys took last Thursday was about measures. Your answers were in degrees, all right, every single time. A length, you could take a tape measure and actually measure it, all right? You can't use a tape measure to measure like a measure of an angle. Okay, I'm using the same word I shouldn't be using. Okay, let's try that again. So length, you would have to use it like something like a ruler. All right, you can use a ruler to get the length. Does that make sense? It would be in something like inches or meters. It's a linear unit, meaning like you can literally take a ruler and measure it. All right? A measurement is in degrees or radians. It is a degree of some sort. So it's like a 30-degree angle, that kind of a thing. All right? We are talking about length today. We do have to use the fact that there's 360 degrees in the circle. So our proportion here is that you're going to take the arc length which is going to be S. So arc length, which we're going to call S, over the circumference. So why does that make sense? Arc length over the circumference is the proportion of the circle, right? The portion over the circle, this part of the circle over the whole, right? Part over whole, do you see that? That gives you kind of the percentage of the circle that you're dealing with. And it is equal to the central angle, theta, over the angle measure of the circle. So that's either going to be 360 or 2 pi. So we're basically looking at two different ratios here.
Hi, Mrs. Brady.
Hi.
Actually, I need you.
Okay, what's up?
Okay,
And I'll explain it a little bit better. So S is the arc length. So if I multiply this by, this is circumference here, right? Circumference is 2 pi r. Do you agree with that? There's 360 degrees in a circle. Do you agree with that? Are we good there? This is the central angle. So whatever our central angle is, we'll put there. If I multiply both sides by 2 pi r, I get S equals 2 pi r theta over 360. Do you guys see that 2 goes into 360? So that's pi r theta over 180. Now, I would prefer for you guys to memorize it like this. Circumference is 2 pi r times theta over 360. So what this is basically saying is to find the arc length, all you are going to do is take the circumference, 2 pi r, right, and multiply it by the percentage of the circle that you're dealing with. Theta over 360 is dealing with the percentage. So if this is a 45-degree angle, I would do 2 pi r times 45 over 360. So I'm taking the circumference over that fraction of the circle. Yes?
That's the equation you used.
Yes, this right here. This is the one I like the most because it makes sense. You are taking the circumference. Remember, the circumference is the whole entire outside of the circle, right? And multiplying it by the fractional part of the circle that you're dealing with. So if this is 45 here, that's 45 over 360. You're multiplying it by that fraction to get the percentage of the circle.
So like not theta, like that's just an example.
They will all have theta.
They
They will have an angle there. And you'll see in the examples in a second.
well, like, I know they'll all have an angle, but is it always going to be like? Never.
Yeah, it must be from carrying and loading and changing.
Okay, so the degrees. That's in degrees. In radian, it's basically the same thing. The only difference here is this 360 here is now a 2 pi because there's 2 pi radians in a circle. So if I multiply by the circumference, you'll notice something really helpful happens in this one. Do you guys see how there's a 2 pi in the numerator and a 2 pi in the denominator? So really, in radians, it's really easy. You take the central angle times the radius. So we're going to put this to work now, and hopefully by the time I'm done with it, it will make a little bit more sense. I want to be able to explain it to you guys in context. I think just seeing letters sometimes makes it even more confusing. Does that make sense? So let me just kind of explain it to you guys in context rather than giving you guys a formula, because maybe you can figure it out without ever having a formula then. All right, does that make sense? All right, so we are trying to find this arc right here. Do you guys see that? But first, we need to understand that our radius is 8 centimeters. So let's start there. Could you find the circumference of this whole entire circle if I asked you to? What would you tell me to do? What'd you say?
So couldn't you just do 60 times 2?
No, I'm not asking you for a measure. I'm asking you for a length. How do I find the circumference? Yes. So we know circumference is 2 pi r, right? So that's 16 pi because our radius is 8. Do you guys understand why that's the circumference? Let's start there. Are we okay there? Okay, so let's think about this now. If this is 16 pi all the way around and I just want to find the part of it, we know that the central angle is the same as the arc, right? So that's 60 degrees out of the whole 360, right? Do you guys see that there? 360, so it's 60 degrees out of the whole entire circle. A whole entire circle is 360, so it's part over whole. Do you guys see that? And if we multiply that by our circumference, we can figure out what our answer is. So what's 16 times 60? Can somebody do 16 times 60 for me? 960 pi over 360, right? So I just multiplied straight across. Do you guys remember multiplying straight across before? So all I did is multiplied straight across. Does 6 go into 96? 6 goes in there once? Yeah, it does. So I'm going to divide top and bottom by 6. Once 36 is 16 over that. And then what goes into both of those? 2? Did you guys try it in your calculators and get the same thing? 8 pi over 3? Is that what you got? And it's in centimeters, guys, because our radius is centimeters. So let's talk about what I did there. I said I know that the whole entire circumference is 16 pi. Is anybody confused on how I got the whole entire circumference? Are we all good there? And then I said, well, we're wanting a part of that circumference, right? And we want 60 degrees of the whole. Well, a whole circle is how many degrees? 360. So we did 60 out of 360, and then we just multiplied and simplified. Does that make more sense, maybe not as a formula, and just remembering it to do it that way? Some of you guys might want to memorize the formulas that are on the other page because you're really good at memorizing, and some of you guys need to understand the process behind it. Does that make sense? We're all going to be different places. I like this better, knowing where everything is coming from personally, but that doesn't mean that's who you are, okay? So let's try if it's given to you guys in radians. Notice that our radius is still 4 centimeters. Do you guys see that? So we can still find the circumference. We know some circumference is 2 pi r, and for us, r is 4. So this time our circumference is 8 pi. So technically, you could say, well, 8 pi times, we know in radians, the whole entire circle is 2 pi, right? Do you guys agree with that? And then you would have 3 pi over 2. But that looks really messy, doesn't it? Does that look messy to you guys? Wasn't there a really easy formula for radians, if you look back to that page? This one might be a good one to remember because of all the fractions. All you have to do is take the angle measure times the radius. And I'll explain to you why that works in just a second here. So we're saying that it might be easier to find the arc length by doing the central angle times the radius. And I'll explain to you guys why this works. Well, our central angle is 3 pi over 2, and our radius is 4. So that gives me 12 pi over 2, which is 6 pi. And that's in centimeters as well. So why does it work that way? Well, look at this. Pi cancels out here and here. Do you guys agree with that? You guys see that one's in the numerator and one's in the denominator? 8 divided by 2 is 4. Now are we right where we were before? Right here? Do you see how that leaves us with 12 pi over 2? Which is 6 pi centimeters. So, again, if you are good at memorizing formulas, this might be the way to go, but you can also do it this way. All right? Do we only have 2 more examples? Those 2? Okay. So So we're going to do these two examples. You guys will have homework. You'll have time to ask me questions. Just make sure you're using your notes. So look at the next one. Is the next one in radians or degrees? Is the next one there in radians or degrees? Degrees. It has a little circle. So we need to find the circumference. We know circumference is 2 pi r. And our radius is what this time? 3 meters. So that's 2 times 3, which is 6 pi. So our whole circle is 6 pi. And we need to multiply it by the part. How many degrees is our arc? And how many degrees are in a total circle? So I multiply straight across. They both end in 0, so I'm going to cancel those out. 9 goes into both of those. 9 goes into 36 4 times, right? Divide that by 10 and 4 go into 2. And then a lot of you guys know how to put this in your calculator now. So if you just want to put in your calculator, did you guys get 5 pi over 2? And this is in meters. Okay, the last one there, is that in radians or degrees? Radians. So we know that there's a specific formula that can help us when we're in radians. We know there's a specific formula when we are in radians, and only in radians. So we can do it this way if we are in radians. We can take our central angle and our radius and find our answer really quickly. And this is the way I would like most of you guys to do it. I will show you the other way just in case you completely do not understand this, just in case you need to figure it out on the quiz. So the central angle is pi over 6, and our radius is 12. So that's 12 pi over 6, which is 2 pi, and this doesn't have units, so I'm just saying 2 pi units. So please do not write this down unless you really want to. Just pay attention for a second here. If you have literally no clue what just happened there, you can find the circumference by using 2 pi r. So our circumference would be 24 pi. Do you guys see that? So we would have 24 pi times, is it pi over 6? Pi over 6, and the whole entire circle in radians is how many radians? In degrees it's 360, in radians it's 2 pi. You'll notice that our pi's will cancel out. 24 divided by 2 is 12. And do we still get 12 pi over 6 again? So do you guys see that if you're really bad at memorizing formulas, this is another way of doing it? Do you guys see both ways? This way for you is easier? I think that this way